Our project is driven by the challenge of integrating complex, multiple practical systems within a resource-constrained, embedded environment. By simulating a tactical authentication and deactivation signaling inspired by CSGO, we aimed to study the signaling between real-time hardware interfaces and secure wireless communication. The core engineering focus lies in implementing a non-blocking polling mechanism that ensures high-frequency responsiveness, allowing the system to simultaneously process ultrasonic proximity data, rendering buffer-driven OLED graphics, and maintain a reliable 2.4 GHz radio handshake. Ultimately, this project serves as a practical exploration of deterministic system design, where auditory and visual feedback loops are synchronized to demonstrate robust error handling and low latency interaction in a time-critical execution window.
Okay, let me introduce the hardware. Here we have in the microbit we have a accelerometer to detect the position, whether it is perpendicular straight on the wall and perpendicular to the ground. And this is the ultrasonic sensor. It detects the distance between the hand and the sensor. If the distance is less than 5 centimeters, people can defuse the bomb. And this is a keyboard. The keyboard is for password input. And we have a button. If we press this button, the bomb will be set. And for actuators, this is the OLED. OLED, when the bomb is set, it will display a math question, and the answer to the question is the password we need to input. And for LED here, it will display the countdown number, 18, 17, 16, and it shows the seconds left until the bomb will explode. And for wireless communication, the 2 megabits communicate with radio. And for wire communication, the diffuser and the keyboard we use wire, and the bomb and the ultrasonic sensor and the OLED we also use wires. And so we use Python to create this project, and 80% of the codes we write by ourselves.
Okay, thank you. Now I will demonstrate how this process works. So first, this is the C4 bomb, and this is the diffuser. So first we have to plant the bomb. So we have to plant it vertically, and then we have pressed the button A. Yeah, and then it will count down from 20 to 19 to 0, and the countdown frequency will increase like tick, and then this is the ultrasonic sensor, and if we use the hand to close enough. Close enough, and then the diffuser will change from a sad face to a happy face, and then we can press the password. And also, let's try again, because the 20 seconds is too small. And also, here there is an OLED screen, and in this is a math function, and then the result of this function is the password. And now I will tell you, it's 14 password. Password is 14. So that's here. And then we can press the password in this extended password 14 1, and then sorry, let's try again. Okay. Smile. Press the password. 1, 4, and then confirm it. And then, if the answer is correct, it will show a smile face. And also, and then the OLED screen will show a nice job. If beyond the 20 seconds you can press the correct password, the bomb will explode. And also, if we like here, if we press the password wrong for 3 times, it will explode right away. Like I will show you. Plant the bomb. And then, okay, smile. Let's press some wrong password, right here. First, the second time, the third time, and then it will play a school, and then here the screen, OLED screen will show a fail. Yeah, and also if you press the wrong password but does not confirm it, you can press the star. Like if you press 1, 1, 5, the 5 is wrong, so you can press the star, and then it will back 1 bit from 1, 5 to 1. And then you can press the right button, and like 7, 1, press it, it becomes the 7, and again it is blank. So press the right password, yeah, and confirm it, and it smile. Yeah, okay, that's it.